25 mind-blowing space facts you won't believe are true. The universe is not what you think. What if everything you believe about the universe is wrong? What if space isn't silent? What if time doesn't work the way you think it does? And what if the universe is far stranger and far more alive than anyone expected? Today you'll see 25 facts that bend physics, break logic, and make even scientists say, "I don't believe it, but it's real." Get ready, because after this video, the universe will never look the same again. Fact 1. The darkest planet ever found. There is a planet orbiting a distant star that reflects almost no light at all. It's darker than coal, darker than black paint, darker than anything you've ever seen. This world, called TRES-2b, absorbs 99% of all starlight. If you stood near it, you wouldn't see a planet. You'd see nothing. A perfect void, outlined only by a faint red glow from its overheated atmosphere. Scientists still don't know why it is this dark. How many things in the universe are right in front of us, but completely invisible? Fact 2. Rogue planets drift alone. Not every planet belongs to a star. Some worlds have been kicked out of their systems and now wander alone in the darkness. No sunrise, no warmth, just eternal night. There may be trillions of these orphan planets drifting silently through the galaxy. And here's the unsettling part. One of them could pass through our solar system without warning, completely invisible until it's too late. Fact 3. Diamond rain is real. On Neptune and Uranus, the pressure is so enormous that carbon atoms compress into diamonds, not metaphorically, literally. This means that deep inside those planets, diamond rain falls like glittering storms. Scientists recently recreated the process in a lab and confirmed it again. So the question is not, does it happen? It's, how many planets made of diamonds are out there? Fact 4. Time moves differently everywhere. Time is not constant. It stretches. It bends. It changes depending on where you are. If you live on a mountain, you age slightly faster. If you lived near a black hole, a single hour could equal years on Earth. Time is not a river. It's an illusion held together by gravity. If time moves differently everywhere, then what is now? Does now even exist? Fact 5. Jupiter protects Earth from destruction. Earth is alive today because Jupiter guards us. Its immense gravity pulls dangerous asteroids and comets away from our planet. Without Jupiter, Earth would have been struck by so many extinction-level impacts that life might never have formed. We owe our existence to a giant gas world that has never seen us and never will. Fact 6. The coldest place in the universe is man-made. We always imagine the coldest places as distant nebulae or empty space, but the coldest temperature ever recorded didn't happen in the universe. It happened in a lab on Earth. Physicists managed to cool atoms to just a few billionths of a degree above absolute zero, colder than any natural place in existence, colder than space, colder than the shadow of a dead star. At this temperature, time almost freezes. Matter stops behaving like matter, and reality itself becomes blurred. What happens to the universe when it's colder than the universe allows? No one knows. Fact 7. Stars make sound. Space is silent to us, but stars sing. Not with voices, but with pressure waves, deep, booming vibrations that ripple through their plasma bodies. Their songs are so slow and massive that their wavelengths can stretch for hundreds of thousands of kilometers. We can't hear them directly, but when astronomers convert those waves to audio, the result is haunting. A slow cosmic heartbeat echoing across the void. And here's the thought that bothers many scientists. If stars can sing, then who or what is listening? Fact 8. The universe has invisible walls. Galaxies don't float randomly. They arrange themselves along massive cosmic walls, boundaries made of dark matter. These walls stretch for billions of light years. We can't see them, we can't touch them, but everything, galaxies, clusters, superclusters, flows along their structure like water along riverbanks. It's as if the universe is built on a skeleton we don't understand. If the universe has walls, what's on the other side? Fact 9. A galaxy with no dark matter shouldn't exist. Dark matter holds galaxies together. Without it, stars should drift apart like sand in the wind. But astronomers found a galaxy, DF2, that has almost no dark matter, and yet it still exists, still rotates, still shines. We don't know why. We don't know how. This galaxy breaks everything we thought we understood. Either physics is wrong, or we are missing something enormous. Fact 10. Space has no temperature. This one confuses everyone. Space isn't cold. It isn't hot. It has no temperature at all, because temperature needs matter, and a vacuum has none. Only when you enter space does the temperature begin to matter. Sunlight can cook you, shadow can freeze you, but space itself? Space is nothing. And nothing cannot be warm or cold. The universe is not a place. It's an illusion made of emptiness. Scientists keep asking, if the universe is emptiness, noise, chaos, and accidents, why does it look so perfectly structured? Why does it follow beautiful mathematical rules? Why does it look like something designed, but by no one? Fact 11. Some stars spin at 600 kilometers per second. Imagine a star spinning so fast, it becomes flattened like a cosmic pancake. Some stars rotate at 600 kilometers per second, so fast that their plasma stretches outward. Their magnetic fields twist violently, and their equators glow like burning rings. If Earth spun this fast, the continents would fly off into space. The oceans would tear themselves apart. The atmosphere would rip away instantly. But these stars keep spinning, somehow stable, somehow alive. How far can nature push the limits before the universe says, enough? Fact 12. Falling into a black hole feels normal. Hollywood lied to you. Approaching a black hole doesn't feel chaotic. You won't see distortion at first. You won't feel pain or stretching. Falling in feels peaceful, silent, slow, almost calm. From the outside, you get stretched into infinity, but from your own perspective, you drift into darkness as gently as falling asleep. And then, we don't know. No one does. Black holes are the only places in the universe where physics ends and something else begins. Fact 13. Neutron stars are impossible. A neutron star is a sun crushed into a city-sized sphere. Just 1 teaspoon of its material weighs as much as Mount Everest. The magnetic fields are so strong, they can rip atoms apart and crush matter into weird states we've never recreated. Standing near one would tear you apart instantly. Yet these objects exist, quiet, cold, unbothered. Neutron stars feel like a mistake the universe allowed to happen. Fact 14. The boat's void, a hole in the universe. There is a place so empty, so dark, so massive, that astronomers call it the Great Nothing. The boat's void is a cosmic hole, 330 million light-years across, with almost no galaxies inside. It's so large that if the Milky Way were at its center, we wouldn't discover another galaxy for tens of billions of years. Some scientists say it looks unnatural. Others say it looks like something removed matter from it. Why does the universe have a hole big enough to swallow hundreds of thousands of galaxies? Fact 15. The Eye of God. In the darkness of space, the Helix Nebula stares outward like a gigantic eye. Blue pupil, orange iris, black pupil in the center. Some cultures believed it was the universe watching itself. Some thought it was a sign. Some thought it was alive. What's inside the center? A dying star, leaving behind a cosmic tear. Why do so many nebulae resemble human symbols? Coincidence or pattern? People ask this all the time. Is the universe chaotic or meaningful? Do we see patterns because they're there, or because our minds can't accept randomness? This video won't answer that, but it will make you question everything. Fact 16. The Great Attractor. There is something pulling our entire galaxy, and we don't know what it is. Not just the Milky Way, thousands of galaxies, whole clusters are falling toward a single point in space at 600 kilometers per second. We call it the Great Attractor, but we have no idea what's doing the attracting. Some say it's a supermassive cluster hidden behind cosmic dust. Others think it's a flaw in our models of gravity. Some whisper about dark matter storms, or even structures outside our observable universe. The scary part? We are moving toward it whether we want to or not. The universe has a current, and we're drifting in it. Fact 17. A star made almost entirely of oxygen. Imagine a star so strange that it breaks every rule of stellar evolution. Astronomers found one, a white dwarf made almost entirely of oxygen, no hydrogen, no helium, just a pure, cold, ghostly ball of glowing blue-white in the dark. No one knows how such a star formed. It shouldn't exist, but it does. When the universe creates something impossible, do we rewrite physics or accept that we don't know anything yet? Fact 18. The hottest planet ever found, 4,300 degrees Celsius. There is a planet so hot, its surface glows brighter than molten metal. It orbits so close to its star that its atmosphere boils away and blasts into space like fire. Temperatures reach 4,300 degrees Celsius, hot enough to melt tungsten, vaporize rock, and turn oceans into plasma. It isn't a world, it's a warning. Not all planets are places. Some are punishments. Fact 19. A planet made of ice that's on fire. This one sounds like a joke, but it's real. Gliese 436b is a world of solid ice. On fire. Gravity squeezes it so tightly that the ice cannot melt. Even at temperatures of over 400 degrees Celsius, imagine a burning glacier that refuses to melt. A planet where physics behaves like a magician. Are we sure we understand the laws of nature, or are we just pretending? Fact 20. You are made of starlight. Every atom in your body, your blood, your bones, your thoughts, was forged inside an ancient star. The iron in your blood, the oxygen you breathe, the carbon in your DNA, all created in supernova explosions billions of years before Earth existed. You are not just in the universe. You are the universe, a piece of a dead star, learning to look back at the sky. Maybe the universe is not empty. Maybe it's trying to understand itself through you. Some philosophers say, we are the universe becoming aware of its own existence. Others say, no, we are just accidents of chemistry. Which one is true? No one can prove it, but everyone will have an opinion in the comments. Fact 21. There are more stars than grains of sand. Every beach on Earth, every desert, every grain of sand you've ever seen, put them all together, and the universe still has more stars. Trillions upon trillions, galaxies beyond galaxies. A cosmic ocean so vast that your mind has no place to put it. And here's the twist. We can only see 1/4,000,000th of them. The rest? Hidden. Lost. Waiting. The universe is not big. It's unthinkable. Fact 22. Space might be flat, but not really. For a century, scientists believed the universe was flat. Straight lines, clean geometry, simple. But the deeper we look, the more the truth bends. Space appears flat on large scales, but curves softly in places, twists near massive objects, ripples with gravity waves, and stretches like warm dough as the universe expands. It is flat and curved and stretched all at once. Maybe the universe isn't a shape. Maybe it's a question. Fact 23. The universe might be conscious. This one divides scientists more than anything else. Some physicists propose that consciousness is not an accident of biology, but a fundamental property of the universe itself. Just like gravity, just like time, just like energy. The structure of galaxy clusters resembles neural networks. The cosmic web looks like a gigantic brain. Coincidence? Pattern? Meaning? If consciousness is everywhere, then the universe may not just contain life. It may be alive. Fact 24. The universe might be a hologram. This is real science, not sci-fi. The holographic principle says that everything we see in 3D, galaxies, planets, you, me, may be a projection from a 2D surface at the edge of the universe. Like a cosmic hard drive, encoding reality. It means the universe might not be what it looks like. It might be math pretending to be matter, light pretending to be space, information pretending to be existence. So what is real? And what is just a projection? Fact 25. You are the universe observing itself. This final fact changes everything. You are not separate from the universe. You are made of the same atoms, the same elements, born in the same ancient fire. A star died so you could breathe. A galaxy formed so you could think. Billions of years of cosmic evolution had to happen exactly right for you to exist at this moment. When you look at the stars, the universe is looking back at itself. You are the universe trying to understand what it is. Scientists argue, philosophers argue, viewers argue, but the truth is simple. The universe is stranger, deeper, and more impossible than anything we can imagine. And the biggest mystery is not black holes or dark matter or time. The biggest mystery is why anything exists at all. Let that thought sit with you. We are moving, not slowly, not randomly, not alone. Our galaxy is being pulled through space. And the strangest part is this: we can't point to the thing doing the pulling. We can measure the motion. We can map the direction. We can watch entire regions of galaxies drift like they're caught in a current. But when we ask the obvious question, what is the source? Everything gets uncomfortable. Because this isn't just about our galaxy. It's about the possibility that the universe contains structures so massive, so hidden, and so far beyond our everyday intuition that they can move entire cosmic neighborhoods without ever showing their face. So tonight, we follow the pull, not to get a clean answer, but to reach the moment where the real question changes. Because by the end of this story, you may stop asking, what is pulling us? And start asking, how much of the universe is still invisible to us? The motion we can't ignore. When people imagine space, they imagine stillness. A quiet stage, planets orbiting calmly, galaxies floating like distant islands. But the real universe is not still. The Milky Way is moving through space at hundreds of kilometers per second, relative to the cosmic background. And it isn't just us. Nearby galaxies are moving too. Clusters of galaxies drift. Whole regions flow in patterns that look less like random motion and more like a river. This is what makes it eerie. Because random motion looks messy. This looks organized. And when motion looks organized at cosmic scale, it usually means one thing: gravity. Something massive enough to pull not just one galaxy, but entire galactic populations. Why this isn't just expansion. At this point, someone will say, isn't the universe expanding? Isn't everything moving away from everything? Yes, but that's not what this is. Expansion is like dots on a balloon moving apart as the balloon inflates. This motion is different. This looks like a drift in a shared direction. A bulk flow, not away from us, but through space. Like we're inside a current that has a destination. And the moment you accept that, the universe stops feeling like a calm, expanding space and starts feeling like a landscape with slopes, because drift implies a gradient, and gradients imply a hidden mass. The Great Attractor. This is where a name appears that sounds like science fiction, but isn't. The Great Attractor. A region of space that seems to be drawing galaxies toward it. Not because someone saw a giant object and pointed to it, but because the motion of galaxies looks like they're falling toward a gravitational center. Imagine standing on a hill in fog. You can't see the valley, but you can feel the slope. You can watch water flow. You can watch loose rocks roll. You don't need to see the bottom to know it's there. That's the Great Attractor problem. We see the flow, but the source is partially hidden. And that raises a dangerous possibility. If there is enough mass out there to influence us this strongly, how much mass can the universe hide from us? The zone we can't see through. Now we hit one of the most frustrating facts in astronomy. There are directions in space we simply cannot see clearly. Not because our telescopes aren't good enough, because our own galaxy gets in the way. The Milky Way is filled with dust, gas, and dense star fields. When we look through the plane of our galaxy, it's like looking through a glowing curtain. This creates what astronomers call a zone of avoidance. A region of the sky where distant structures are harder to detect and harder to map. And inconveniently, the direction of the Great Attractor sits close to this obscured region. So we're trying to map a gravitational giant through a cosmic blind spot. Which means something important. Even in 2026, even with modern surveys, the universe is still hiding behind our own local fog. Laniakea, the supercluster we live in. Here's the next twist. We don't live in a random neighborhood. We live inside a structure. A supercluster scale structure. Astronomers gave it a name, Laniakea. It's not one cluster. It's a vast region, an enormous basin of galaxies and galaxy groups, flowing along cosmic filaments like rivers of light. In this picture, galaxies are not isolated. They're connected. They form highways. They stream toward dense nodes. And if you zoom far enough out, you see something haunting. Our motion is not just the Milky Way doing its own thing. It's the Milky Way participating in a larger flow. Like a leaf inside a river current. You don't ask why the leaf moves. You ask where the river is going. The dark flow question. Now we enter the controversial zone. Some observations over the years hinted at something even stranger. That this drift might not stop at the Great Attractor. That there could be an even larger scale motion. A flow pointing towards something beyond the structures we've confidently mapped. This idea was called dark flow. To be clear, this is debated. Some scientists argue the evidence is weak, or could be explained by measurement limitations. Others think it points to something real. But the reason it matters is not whether the term is perfect. It's what the possibility suggests. That our visible universe might be embedded in a larger structure. That our cosmic map could be incomplete in a deeper way than we're comfortable admitting. And if that sounds like a stretch, remember, every time humanity thought it had the full map, the map got bigger. What could be pulling us? So what are the actual candidates? The first is simple. A massive concentration of galaxies and dark matter hidden behind dust, distance, and observational gaps, creating a gravitational slope we're sliding down. The second is more subtle. Not one object, but a network of mass so large that the idea of a single attractor is just a simplified label for a much wider structure. The third is the most unsettling. that the motion reveals something missing in our model. Not necessarily new physics, but missing inventory. Mass we haven't counted properly, structures we haven't mapped, biases in how we measure distance and velocity at extreme scale. And this is where the story becomes personal. Because the universe we experience is the universe we can measure. If measurement has blind spots, reality has blind spots, at least for us. And the great attractor problem is basically the universe reminding us, you are not seeing the full picture. Here is the part that changes the tone. This is not just a curiosity about galactic motion. It's a warning about knowledge. Because the pull tells us something simple. There are forces shaping our cosmic environment that do not announce themselves. We detect them indirectly. We infer them from motion. We see effects and reconstruct causes. That means the universe can influence us without being visible. And once you accept that, a new question becomes unavoidable. If something can pull an entire region of galaxies while remaining partly hidden, then what else is shaping reality without being obvious? What else is sitting behind our blind spots? What other structures exist in the universe that we've simply failed to map because our perspective is limited? And now the final question. Do you think the hidden pull is just a normal consequence of massive structures we haven't fully charted yet? Or is it a sign that our cosmic map is missing something fundamental? Because those two options feel very different. One says, we'll find it eventually. The other says, the universe may always stay ahead of our ability to fully describe it. So tell me what you think. Is this mystery just a hidden mass? Or a hidden truth about how little we actually see? Write your theory in the comments. And if you had to bet, do you think the universe is mostly mapped or mostly unknown? We keep saying the same thing about Betelgeuse. It's about to explode. It's a ticking cosmic time bomb. It's giving us warning signs. But here's the uncomfortable question no one likes to ask. What if Betelgeuse isn't warning us at all? What if the signals we're obsessing over are not messages, but misunderstandings? Because if this star, visible with the naked eye, can confuse us this deeply, then how fragile is our confidence about the universe as a whole? Stay with this thought. It matters more than the explosion itself. The star we thought we understood. Betelgeuse sits about 650 light-years away, glowing red in the shoulder of Orion. It's massive, unstable, near the end of its life. Astronomers agree on one thing. Betelgeuse will explode as a supernova. What they don't agree on is everything else. When, how, what the signals actually mean. Over the years, Betelgeuse has dimmed, then brightened, and dimmed again. Its surface appears to boil. Its shape subtly changes. Its brightness follows cycles we don't fully understand. Every time something unusual happens, the same conclusion rushes in. This could be it. But here's the problem. Stars don't follow our timelines. They don't care about our expectations. And they don't send countdown clocks. At this point, explanation starts to blur into assumption. The illusion of signals. One of the most unsettling claims about Betelgeuse is its rotation. Data suggests it may be spinning far faster than physics predicts for a red supergiant of its size. So fast that, on paper, it shouldn't be possible. And that raises an obvious question. Did Betelgeuse somehow gain extra angular momentum? Did it consume a companion star? Did it steal spin through stellar cannibalism? Or are we seeing something that looks like rotation, but isn't? Because Betelgeuse's surface is chaos. Enormous convection cells, some larger than entire planetary orbits, rise and fall violently, moving gas at incredible speeds. If parts of the surface are rushing toward us, while others move away, the Doppler effect shifts their light. Blue here, red there. From a distance, through limited resolution, that chaotic mosaic can masquerade as smooth rotation. In simulations, this illusion fools observers most of the time. So now, we face an uncomfortable possibility. What if Betelgeuse isn't spinning wildly at all? What if we've been confidently explaining an illusion? When models start to crack, this isn't just about one star. Betelgeuse is forcing us to confront something deeper. Our models of stellar death are built on patterns, on averages, on assumptions that usually work. But extreme stars live at the edge of those assumptions. Betelgeuse doesn't behave like a clean textbook object. It behaves like a turbulent, unstable system, where multiple processes overlap, interfere, and mask each other. Dimming could mean dust, or internal pulsations, or surface upheaval, or something we haven't even named yet. When multiple explanations fit the same data, confidence becomes dangerous, because nature doesn't care which explanation feels elegant. And at this point, the question changes. Are we observing the star, or are we observing the limits of our tools? The dangerous comfort of soon. Let's talk about the word everyone loves, soon. In astronomy, soon can mean tomorrow, or 10,000 years, or 100,000 years. Yet every unusual fluctuation gets translated into urgency, because urgency feels meaningful. But consider this. Life on Earth has survived nearby supernova before. Evidence of stellar explosions exists in our planet's geological record. And yet, here we are. That doesn't mean supernova are harmless. It means distance matters. Betelgeuse is far enough away that its eventual explosion will be spectacular, not catastrophic, bright as the full moon. Visible even during the day, a cosmic event we can watch safely. So why does it feel like a threat? Because uncertainty is uncomfortable. and we instinctively turn uncertainty into trauma. The companion that changed the story. There's another twist. For decades, astronomers suspected Betelgeuse might not be alone. A hidden companion star, small, faint, difficult to detect, could explain long-term brightness cycles. Recent evidence suggests this companion may be real. And if it is, it reshapes the entire narrative. Some cycles once linked to imminent collapse may instead be orbital interactions. That means one of our strongest countdown signals might not be a countdown at all. It might simply be celestial choreography. And suddenly, Betelgeuse looks calmer, still unstable, still destined to explode, but not necessarily in a hurry. The bigger question we avoid. So here's the question we rarely ask out loud. What if Betelgeuse isn't exceptional, but revealing? What if it's showing us how often we mistake complexity for meaning? If we can misread something this close, this bright, this studied. What about distant galaxies? Exotic physics? Early cosmic events? This isn't a failure of science. It's a reminder. Science progresses not by certainty, but by learning where certainty breaks. And Betelgeuse sits exactly at that breaking point. The provocation. Betelgeuse will explode, just not on our schedule, not on our terms, and not with the clarity we want. The real lesson of this star isn't about destruction. It's about humility. Because the universe doesn't owe us warnings, it doesn't owe us timelines, and it certainly doesn't owe us comfort. So the next time we say, "We understand this," we should ask, do we understand it? Or have we simply learned how to describe our uncertainty? If this kind of deep, honest exploration of uncertainty matters to you, please like the video and subscribe. It genuinely helps this channel grow, and it tells us you're interested in questions that don't come with easy answers. What if black hole singularities are a lie? What if I told you that one of the most solid ideas in physics might actually be completely wrong? For 100 years, we believed that inside every black hole lies a singularity, a point of infinite density, infinite gravity, and the complete collapse of space and time. But what if that point doesn't exist at all? What if everything we know about black holes, gravity, and even the Big Bang is built on a misunderstanding? Today, we're diving into a theory so bold that even some physicists refuse to discuss it publicly. And yet, new observations from JWST and advanced quantum models suggest something shocking. Singularities might be an illusion, a mathematical artifact, a mistake that has survived for a century. And if that's true, then everything about the universe changes. Let's go. What is a singularity? The classical model. Classical physics says, a singularity is a point, zero volume, infinite density, infinite gravity. Laws of physics break down. But wait, if the laws break down, then maybe the object doesn't exist. Einstein himself wrote, "A singularity means the theory has failed." He never liked the idea. He knew nature doesn't allow infinities. So why did we believe it for 100 years? Because there was no way to test it. Until now. Where the math breaks down. A singularity does not appear because nature creates infinity. It appears because the math collapses. In physics, infinity is not a physical object. It is a warning sign, a red flashing light saying, your theory no longer works here. General relativity predicts a singularity because it doesn't know how to describe matter at extremely high densities. Quantum mechanics predicts chaos because it doesn't know how to handle extreme gravity. The clash of these two theories creates the illusion of an infinite point. The singularity isn't a physical place. It's the moment our equations surrender. Quantum gravity, the truth inside a black hole. At the smallest scales, space is not smooth. It is built from tiny quantum units, granules of geometry itself. You cannot compress space beyond these limits. This means a singularity cannot form. Not theoretically. Not physically. Not ever. Instead of an infinitely small point, the center of a black hole becomes a quantum core, a tiny region of maximum possible density, but never infinite. No infinities, no breakdown, just quantum geometry doing its job. This changes everything. The bounce model. Black hole gives white hole. If matter cannot collapse into a point, what happens when it reaches the limit? Quantum gravity offers a radical answer. It bounces. Matter collapses, slows, stops, then reverses direction and explodes outward. A black hole may eventually turn into a white hole, a time-reversed version that releases everything the black hole once consumed. Some physicists now believe the Big Bang itself was just such a bounce. Not the birth of the universe from nothing, but the rebound of a previous universe, compressed to its quantum limit, and then released. A cosmic cycle. A universe that inhales and exhales. The observer. Information paradox blows IT all up. There is one law in physics. That destroys the idea of a singularity completely. Information cannot be destroyed. But a singularity? It erases everything. This is the heart of the famous information paradox. Stephen Hawking eventually admitted, singularities cannot be the final answer. Modern theories suggest that information stays encoded on the event horizon, or is stored in quantum geometry, or escapes through the bounce as a white hole. No matter which is true, a singularity is impossible. It would break the universe, and the universe does not break. JWST just made the problem worse. Then came the James Webb Space Telescope, and suddenly, everything we thought we knew collapsed again. JWST discovered something impossible. Supermassive black holes existed just 400 million years after the Big Bang. But according to classical models, this should not be possible. There wasn't enough time for black holes to grow so large. Unless our model is wrong, unless black holes form differently, unless the center is not a singularity at all, JWST may be the final nail in the coffin of the classical theory. If singularities aren't real, then what is? If singularities do not exist, then the universe looks completely different. The Big Bang wasn't a point. Black holes are not infinite. The universe did not begin from nothing. Time did not start at zero. The cosmos may be eternal. Reality may be quantum at every level. Instead of a one-time miracle, the universe becomes a cycle, a series of collapses and rebounds, births and rebirths. A universe that grows, contracts, and renews itself, like a cosmic heartbeat. The controversy? What scientists won't say out loud. And here's the part few scientists are willing to say publicly. We know singularities don't make sense, but rewriting the theory would change too much. Admitting that singularities are wrong means rewriting. Textbooks, cosmology, black hole physics, the origin of the universe itself. It's easier to keep teaching the old model than to admit the foundations were shaky all along. But once you remove singularities, something terrifying happens. The Big Bang is no longer the beginning. The universe has a history before time zero. The story we learned in school collapses. If the universe didn't begin as a point, then what really happened? This is the question that makes even physicists uncomfortable. The next 5 years will change everything. Over the next few years, JWST will observe deeper into the early universe. LIGO and Virgo will detect new gravitational waves. Quantum gravity models will grow more precise. We may see evidence of a white hole. We may uncover signs of a cosmic bounce. We may prove the universe has no beginning at all. If singularities are truly an illusion, then the universe is far older, far stranger, and far more beautiful than we ever imagined. And before we finish, don't forget to subscribe. What comes next will blow your mind. Because the next discovery may rewrite the story of the universe forever.